Hi, I'm Jim Anderton, Director of Content here at Engineering.com. What brought down the Russian jet in Egypt? Last week's tragic crash of an Airbus A321 in the Sinai took the lives of all 224 people on board. And like all tragedies that occur in the Middle East, it's become a political football. Now, between claims of responsibility from ISIS, reports from U.S. intelligence sources about flashes on satellite imagery, and statements from sources as high level as British Prime Minister David Cameron, everyone has a theory about the cause. But few are thinking about the engineering angle. Metrojet Flight 9268 was operated by a Russian airline, so it's understandable that the politicos assume a connection between this tragedy and terrorism, given Vladimir Putin's involvement in the conflict in Syria. But somewhere, lost in the ludicrous media speculation about the true cause of this crash, a simple fact has emerged. In 2001, the same Airbus A321 aircraft had a tail scrape incident that required structural repair. Now, it's not uncommon for a pilot to occasionally over-rotate on takeoff and rub the tail against the runway, but the consequences can be more serious than they look. Modern jetliners are built with monocoque construction, meaning that the external skin is an important and stressed structural part of the fuselage. Now, jetliners are also very large, lightweight pressure vessels. The critical rear bulkhead is particularly vulnerable if damaged, and part of the repair procedure for tail strike incidents is an inspection of that bulkhead. Now, approved repair procedures range from riveted doubler plates to replacement of the entire bulkhead. But as you mechanical engineers out there know, stopping crack propagation is more complex than just drilling holes. For an airliner fuselage, the pressure loads are cyclical, occurring with every takeoff and landing. The Metrojet A321 had over 20,000 cycles, which is not unusual for a mid-sized airliner on European routes entering the latter half of its service life. Now, could an inadequate repair of a damaged rear pressure bulkhead lead to catastrophic depressurization and loss of the aircraft? Without doubt, because it's happened before, most tragically in August 1985, when a Japan Airlines 747 suffered an explosive decompression due to failure of the rear pressure bulkhead. The failure released cabin pressure into the normally unpressurized tail section of the fuselage, blowing off the vertical stabilizer. Now, that aircraft had some 18,000 cycles in its logbook, and it had been repaired after a tail strike incident 7 years earlier that damaged the rear pressure bulkhead. Now, in that case, Boeing repair technicians used 2 riveted splice plates instead of the approved procedure, which called for a single continuous doubler. That resulted in a repair with 70% lower resistance to metal fatigue, according to the FAA. Now, Boeing later calculated that the incorrect repair would fail after approximately 10,000 cycles. That aircraft, in fact, underwent 12,318 cycles from the time of the repair until the crash. So it's happened before. An inadequate repair of a tail strike incident that damages the rear pressure bulkhead can rear its head years later and result in breakup of the aircraft at altitude. Could a bomb have brought the aircraft down? Sure. But the engineering reality is that the aircraft had endured damage to a critical part of the airframe which can produce an in-flight breakup of the aircraft if it fails at altitude. Now, the clues are there along the desert floor. The flight data and cockpit voice recorders may help, but metallurgical examination of the wreckage by the accident investigation team will be definitive, and until they render judgment, it's irresponsible to speculate about other causes.